Now, to look at what are the parts of this. The whole thing here is referred to as the light reaction. That light reaction is broken into two parts. The two main parts are photosystem 1 and photosystem 2. Now the confusing thing is these are named in reverse. If you really wanted to be honest about it, this is photosystem 2 and this is photosystem 1. But we oftentimes talk about it as photosystem 2, which is actually the first one, and it's named that because they found it second. They found photosystem 1 first. Photosystem 2 excites the first electron, drives the electron transport chain, and breaks down the water. So its job, all of this photosystem 2 stuff, it's the beginning of the light reaction. And then this is photosystem 1. Now photosystem 1 is all it does is excite these electrons and then turn it into NADPH. So it produces let me just change this arrow here. It creates for us NADPH. Just rewrite this all over. So photosystem 1 and it makes NADPH. But then you also have photosystem 2 over here. It pumped all these hydrogens. Since these want to be out here, this became increasingly more positive. This became increasingly more negative. So they want to get out over here. For them to get out over here, they have to make ATP. So technically, all of what happens here is kind of the responsibility of 2. Now this ATP synthase can be anywhere in the membrane. Now the individual parts, what are their names? This is the water breaking enzyme. That'll be fine for us. This is chlorophyll. This one's a chlorophyll over here. This is the electron transport chain from here over to here. This one is NADPH reductase. Because it adds electrons, it's reducing the charge of the NADPH, so it's NADPH reductase. And then this is ATP synthase, because it makes ATP. And ATP is a very high energy molecule, and NADPH is a very high energy molecule. Those are what we're going to send up to the Calvin cycle to actually put our sugar together.